These are notes on how to find unknown measures in similar figures. Remember from before that in similar figures, corresponding angles are congruent, so that means that each of the angles in the small trapezoid are going to match up with each of the angles in the larger trapezoid. So we can see just like that. When you are labeling corresponding angles, you would use similar markings. So if I do one arc in that angle, I could do two arcs in this angle. I could do three in the third angle and four in the fourth angle. Those symbols mean that the angles that match up with those same symbols are congruent, or they are equal. In similar figures, corresponding side lengths are proportional. So that means the side length here that corresponds to this side length, those two are proportional. I can label the other side lengths. We can do the top or the shorter side of the trapezoid. Then we can label the third one. We'll color that black. And the fourth one, we can color that one red. Now those are the corresponding sides, they match up. If the figures aren't already turned the same direction, it may help to redraw one of them so that they do match up the same way. In our first example, we have two similar triangles and we need to find the unknown value of x. To start, I'm going to label the corresponding sides. So I can do the shorter side of the small triangle compared to the shorter side of the bigger triangle, and the medium length side of the small triangle to the medium length side of the big triangle. Now it might help to set up your proportion by labeling which pieces you're going to do where. So if I do the small triangle length over the large triangle length, that might help me keep everything matched up. So the first triangle has a short length of 6. The large triangle has a short length of 9. So I'm matching up those two measurements. The second half of the ratio, or the proportion, I'm going to match up the small medium side to the large medium side. So that's the proportion. The first ratio represents the first triangle. The second ratio represents the second triangle. Now I can use cross products to solve. So we're going to multiply 6 times x. And because these are proportional, we know that that is equal to 8 times 9. Now we can simplify each side. 6 times x is 6x. 8 times 9 is 72. And we're going to divide by 6 on each side to get the value of x. Now this is where if you need to work something out off to the side, you can. 72 divided by 6. 6 goes into 7 one time. And 6 goes into 12 two times. So we can see that x equals 12 is our final answer. Now because it had meters as a side length measurement, we're going to make sure that we label meters down here as well. So our final answer is x equals 12 meters. In our second example, the polygons are still similar, except this time they are not facing the same direction. So we're going to be really careful when we label that this side length in red corresponds to this side length, which is now on the bottom. And then we could do the same thing. The longer side that makes the right angle on the first triangle matches the longer side that makes the right angle on the second one. So now when I set up the two ratios to make a proportion, we can do the large triangle over the small triangle. The first proportion represents the red segment, so we will do 9/5. The second one represents the longer side, so we will do x over 8. Put an equal sign in between to make it a proportion, and now we can solve. 9 times 8 equals 5 times x. So we get 72 equals 5x, and then we're going to divide by 5 on each side. 72 divided by 5. 5 goes in one time. 5 goes into 12 twice. And now we're going to add a decimal point so we can bring down the 0. And 5 goes into 20 4 times. So we get a value of 12 and 4/10 for x. There are no units labeled, so for this one it's okay to leave that off. In our next example, they are facing the same direction, so we can set up our first fraction as 9/21 and our second ratio 6 over x. And just like before, we'll use cross products to solve. 9 times x equals 21 times 6. We'll multiply 21 times 6 first to get 126. And now we're going to divide by 9 on each side. So 126 divided by 9. And we get x equals 14 as our answer. Again, there are no units, so we'll just leave x equals 14 as our final answer. In our next example, we only have 2 of the side lengths labeled. So we have x and we have 12 feet. The other ones, we don't know what they are, but we do have a ratio in the instructions. It says the 2 quadrilaterals are similar. The ratio of the perimeters is 3:4. Find the value of x. So we're going to write 3:4 as our first ratio, and since 3 is less than 4, that is the small side or the small figure compared to the large figure. So in our proportion, because the first quadrilateral is smaller, I know to put x in the numerator and 12 in the denominator. Now I could use cross products like before. However, I can also just multiply 4 times 3 to get 12. So I'm going to do 3 times 3 to get my value of x. So x equals 9. And we do have units, so we're going to add feet to make our final answer x equals 9 feet. Okay, another example just like before. So we can do short side in the small one compared to short side in the large one. And the second ratio, we're going to do 9/27. We need a proportion, so we're going to put an equal sign in between. Now remember, we also have the method where we can simplify one of the fractions. If I divide 9 divided by 9 and 27 divided by 9, the green fraction will simplify down to 1/3. Like I said before, you can still use cross products, but if we can use a simpler method, we might as well. So now, 1 times 4 is 4. So 3 times 4 gives us the value of x. So x has to equal 12. Okay, just like before, we can set up short side to short side and set that equal to long side over long side, x over 12. Just like before, we can use multiplication to solve the proportion. So multiply by 4 on top and bottom, and we get x equals 28. Now, as I'm setting these up, there are many more ways than just the one to set this up. Just so you can start to see, we can also set up our proportion and do 7 over x equals 3 over 12. So that would be a within figure relationship. The first one was a between figure because I was going from the big one to the small one. Now I'm going from the short side to the long side within the same figure. Okay, 3/12, if I divide by 3 on top and bottom, that will simplify down to 1/4. So I get 7 over x equals 1 over 4. And then I can multiply 1 by 7 and 4 by 7. So I get x equals 28. Now again, it's just a second way of doing it. I just want you to see that there is more than one way to set up your proportion. Now we're going to move on to some word problems. This one says a street light casts a shadow of 12 feet. A 6-foot person casts a shadow of 3 feet. Assume the triangles are similar. What is the height of the street light? To start, we're going to sketch out a picture. So we're going to draw a street light. And it says that it casts a shadow of 12 feet. So the street light is what we're trying to find, so we'll label that with an X. And this is where the shadow falls. And we'll label the shadow 12 feet. If you want to sketch that in a little more shadow-like, you can. Okay, and then we have a 6-foot person, so they are standing on the ground. And they cast a 3-foot shadow. So their shadow is 3 feet, and the person is 6 feet tall. Okay, again, it's really helpful to set up your picture, then you can set up your proportion. So this one we can do x 12ths equals 6/3. So this is my within figure relationship. And I can go from 3 to 12 by multiplying by 4. So I'm going to multiply 6 times 4 to get my answer of x equals 24. We have a word problem, so we need a word unit. So x equals 24 feet as my final answer. Our next example, a rectangular picture has a width of 5 inches and a perimeter of 24 inches. The picture frame is similar to the picture that will fit inside. The width of the picture frame is 8 inches. What is the perimeter? So let's sketch out a picture. And this one is actually representing the picture. And we have a second one that will represent the frame. Okay, it tells us that the picture has a width of 5 inches, so that's the shorter side, and a perimeter of 24 inches, so we'll label that down below. The picture frame is 8 inches, and we want to know the perimeter of the frame. So we'll do a between figure relationship, 5 over 8, so small side compared to large side, equals small perimeter over large perimeter, so 24 over x. Just like before, we will use cross products. So 5 times x equals 8 times 24. Eight times 24 is 192. And we still have 5x. Now we're going to divide both sides by 5. And we're going to get x equals 38.4, and the units were inches. So the perimeter of the frame is 38 and 4/10 of an inch.